Good morning, students. As you know very well, we have done first 5 questions of the NCERT exercise of Unit 5 Thermodynamics. So today we will keep continue and we will do some more questions of the NCERT exercise of thermodynamics. So we are started from question number 6. Here question number 6 is a reaction A plus B. A reaction A plus B. These are the reactants. After reacting with each other, they are producing C plus D plus Q is found to have positive entropy change. Means value of del S is positive. The reaction will be, some options are given to you students. Here this is the reaction and here entropy change is positive, it is greater than 0. Then student, this reaction can be possible at high temperature only, possible only at low temperature, not possible at any temperature, or possible at any temperature. So which one is the right option for this? Students, you know very well, if del S is greater than 0, then process is spontaneous. And for verification, students, we can do this one also. Gibbs free energy. You have studied about that. Del G is equal to del H T del S. This is the relation. Then students, here you can see during this reaction heat is evolved. Heat is evolved means it is exothermic reaction because heat is releasing, so it is exothermic reaction. Okay, so students, from here I can write this del H will be negative. Clear or not? And you know very well, this del S is positive. This is positive. So overall, this del G value will be, this one is negative and this one is also negative. So overall it will be negative. So you will get value of del G less than 0. Value of del G, you will get negative here, or we can say change in enthalpy value is less than 0. And student, you know very well, for spontaneous reaction, we have discussed yesterday about this. For spontaneous reaction, for spontaneous process, value of del G will be less than 0 and value of del S will be greater than 0. Means student, this process, this reaction is spontaneous, and spontaneous reaction is that which occur itself, which occur without any external agency. Clear or not? So we need not to provide any temperature to this one. So at any temperature, this reaction can be possible. So here option 4, it will be the right option for this. This question is correct. Is clear to you or not? Yes. Then students, let's see the next question. Here question number 7 of NCERT exercise. In a process, 701 joule of heat is absorbed by a system. Heat absorbed. That is 701 joule, and 394 joule of work is done by the system. Here heat is absorbed. So work done by the system. H 394 joule. What is the change in internal energy for the system? Students, you know very well about the relationship between internal energy, heat and work in first law of thermodynamics. Okay, so according to the first law of thermodynamics, according to first law, according to first law of thermodynamics, students, del U is equal to Q plus W. Students, here sign convention will depend on either heat is absorbed by the system or heat is released by the system. If heat is absorbed, if heat is absorbed by the system, then sign will be positive. And if heat is released by system, then it will be negative. And if work is done on the system, work is done on the system, it will be positive. And if work is done by the system, then it will be negative. Then students, you will see sign convention also. It will be negative. Then students, here heat is absorbed, means this will be positive, heat will be positive here, but work is done by the system, means this work done, it will be negative. Clear or not? Yes. Or student, directly you can put the value here. Q is 701 plus W is work is 394. So 701 minus 394. This one will be the internal energy. Subtract this. What will you get? 11 minus 4. 7. 9 minus 9. 0. 6 minus 3. 3. Means you will get 307. What will be the unit? Joule. Because internal energy, it is also energy. So, joule. Okay, students. So, this was the question of the first law of thermodynamics. Okay, you will keep in mind about the signs. If heat is absorbed by the system, then it will be positive, and if heat is released by the system, then you will take negative. Clear? If work is done on the system, then it will be positive, and if work is done by the system, then it will be negative. Clear? If you know about the sign convention, then simply you can solve question related to the first law of thermodynamics. Any doubt in this? No. Okay. What is the problem here? Okay, so next question is question number 8. The reaction of cyanamide, this NH2CN, it is solid in state. You will write physical state also, because in thermodynamics we need to see about the physical states also. Then students, it react with dioxygen. It react with dioxygen, was carried out in a bomb calorimeter, and del U was found to be, del U is given, this is minus 742.7 kilojoule per mole. At 298 Kelvin, temperature is given 298 Kelvin. Calculate enthalpy change. Calculate the enthalpy change. Means del H. Here reaction is NH2CN in gaseous form it is. It is in gaseous form, but not in solid form. In gaseous form, react with oxygen. It is producing nitrogen gas plus CO2 plus H2O. It will be solid air, not gaseous. Then students, here this equation is given to us. Here change in internal energy is also given to us, and here temperature is also given. We need to calculate del H. So what is the relationship? Del H is equal to del U plus P del V plus P del V. And students, second relationship, because here volume is not given to us, here temperature is given to us, then we can write del H is equal to del U plus del NG RT. You know very well, na? For ideal gases, PV is equal to nRT. PV is equal to nRT. So I can write PV in form of the temperature and gas constant. Here n is the number of moles change. Okay, so here number of moles of react product minus this Ng is a number of moles of gaseous product. Keep in mind that of gaseous product, G is showing the gaseous product minus number of moles of the gaseous reactant. You can write in this way. This del Ng is equal to number of moles of reactant of product minus number of moles of reactant. Clear? Then student, you will see number of moles of the gaseous substances only. So here you can see this is in liquid state. So two molecules are in gaseous state. One is N2. So how many moles of N2? 1. And how many moles of CO2? 1. So total numbers of the moles of product in gaseous form 2. 1 plus 1, 2. And here you can see this is in solid state, only this one is in gaseous state. And how many moles are there? There are 3 by 2 moles. There are 3 by 2 moles. Then students, in reactant side, number of moles for gaseous atom is 3 by 2. So del Ng will be the number of moles of gaseous atom in product side minus number of moles of atom in reactant side. Clear? Then number of moles of gaseous in reactant side. So here 1 plus 1, 2, and here 3 by 2 only. Then student, you will get 0.5. You will get 0.5. It is clear to you or not? Then student, you can put value here. Del H, you will calculate. Del U, this value is given to you. This is minus 742.7 plus value of Ng is 0.5. R is gas constant. R is gas constant, and students here del U is given in kilojoule per mole. In kilojoule per mole. So value of R we will also take in kilojoule per mole. So it is 8.314 into 10 raised to power minus 3. Okay, kilojoule per mole. Then students, you will put this value. You will put this value also. It is 8.314 into 10 raised to power minus 3 into T. What is the value of temperature here? It is 298 into 298 into 298. Then student, if you calculate, you will try to calculate this one. This value of nRT, you will get around 1.2. You will get around 1.2 plus 1.239. Okay, then students, you can calculate this, and finally you will get your desirable answer from here. Clear to you or not? Yes. One more time you can see. Students, here equation is given to us. Equation is given to us. Del U given to us. Okay. Temperature also given, and we need to calculate enthalpy change. We know one relationship between internal energy and enthalpy change. So this is the relation. Del H is equal to del U plus P del V. Okay. But here volume and pressure are not given to us. Here temperature is given. So students, other relation we also know about ideal gas equation. PV is equal to nRT. So we can put this value. PV is equal to nRT. So how can we calculate number of moles of change in moles of gases? Okay. So here number, you will keep in mind number of moles of gases only you will consider. Okay. So number of moles of gases in product side minus number of moles of gases in reactant side. I am not considering this one because it is in solid state. Okay, you will take only moles of gaseous state. Here nitrogen is gas and CO2 is gas, but water is liquid. So I will not consider this one. Here only I will consider this one. 1 plus 1, 2 mole. In product side and in reactant side, this is in solid state. So I will not consider this one. Here only this one is in gaseous state. So I will take moles of this only. These are 3 by 2. So 2 minus 3 by 2, 0.5. Clear? Now we have value of del U also because already given to us. Value of Ng we have calculated. R value, R is gas constant. Okay. So we can take 8.314 into 10 raised to power minus 3 kilojoule per mole into T. Temperature value is also given to us. So by calculating only we can find out our answer. Any doubt in this? Yes. One more question you will see, students. Calculate number of kilojoule of heat necessary to rise the temperature of 60 gram of the aluminium from 35 degrees Celsius to 55 degrees Celsius. Heat capacity of the aluminium is 24 joule per mole per Kelvin. Okay, students, you know very well about the heat capacity. Here, molar heat capacity is given. Molar heat capacity is given. Molar heat capacity you can denote by Cm. It will be Q by M del T. Note M, we can take N because N is number of moles. N is number of moles. Then students, here molar heat capacity is given to us. Calculate number of kilojoule of heat. Means we need to calculate Q here. We need to calculate Q. So how can we calculate? Q is equal to Cm N into del T. Then students, we need molar heat capacity. It is already given to us. That is 24 joule per mole per Kelvin into N, number of mole. How can we calculate? Here 60 gram of aluminium. 60 gram of aluminium is given. So given weight 60 gram. For aluminium it is. So you can calculate number of mole. How can you calculate? Given weight by molecular weight. So given weight is 67 and molecular weight. Given weight is 60 and molecular weight will be 27. So from here you can calculate the number of moles. Clear or not? Then students, del T. Here temperature 35 to 55, it is increasing. So T2 minus T1, 55 minus 35, 20 degree. Okay. After calculating all these, so from here N, you can calculate 60 by 27 into del T, 55 minus 35, 20. You can calculate this. Okay. So thank you. Have a nice day.